Now, let's talk about standing waves in a column of air. Standing waves in a column of air. You know, guys, there are musical instruments, right, that produce sound, as oscillating as the air inside it oscillates, right, as the air inside it oscillates. We have two types of these instruments. One at closed tube end, one at open ends. Yani the first one we may have like this, closed end one, or closed end tube. If I generate sound here, same thing, guys. These sound waves are outgoing, or part of these sound waves will be reflected. As a result of that, they will interfere constructively and destructively at certain positions, right? This is, again, it's a standing waves, but instead of string, now we have a standing waves where in a column of air. The air also will act as a string. Again, guys, here we have outgoing waves, here we have reflected waves. They interfere at certain positions where they are called nodes destructively, or they interfere at certain positions where they are called anti-nodes. They are interfere constructively. Same thing, same procedure, same حتى explanation for everything. I want to show you this. Okay, let's watch this video.
Sound. We're going to produce standing waves in a tube with a sound source. I'll use either a tuning fork or a speaker. I'll produce a constant frequency sound, and I'll place that sound over a tube that is open at one end and closed at the other end. Sound over a tube that is open at one end.
Okay, guys, if you look here, guys, this is a tube, right? Consists of air. Look to this. This is the first end, open end. The second end here, near to the water surface, it's a closed end. Yani the water inside the tube will make a closed end for the air. So it's a closed end by water here. I used water so I can move the tube up and down easily.
And closed at the other end. I'll try to find the length of the tube that produces a standing wave inside the tube. I'll know there's a standing wave when I hear an increase in the volume of the tone. I can adjust the length of the tube by raising or lowering it in the water. The water end of the tube, of course, is the closed end, and the open end is up here where I will place the sound source. We'll use 3 frequencies of sound. I'll use a tuning fork for 1000 hertz, and then I'll use the speaker for 512 hertz and 256 hertz.
Okay. Okay, guys, as what I mentioned before here, this is the closed end for air, right? Closed end for air, and here below this surface there is no air, right? It's a water. Here there is what? An open end. Here there is what? An open end. Okay, clear? Now look how will the sound wave will be produced here. Okay, listen now.
I'll raise the tube. You listen for an increase in volume. Look at the markings on the and the open end is up here where I will place the sound source. We'll use 3 frequencies of sound. I'll use a tuning fork for 1000 hertz, and then I'll use the speaker for 512 hertz and 256 hertz. I'll raise the tube. You listen for an increase in volume. Look at the markings on the tube. Find the length of the tube that you hear the increase in volume and record that length of tube in your data sheet.
What he will do now, if you see here, he will use tuning fork. Tuning fork, guys, when you hammer it by a bunch or anything else, it will produce a sound wave with a specific frequency, which is 1000 hertz, like our specific frequency. Sorry, for this tuning fork, it's 1000 hertz. Now he will place this tuning fork above the tube, like what did we see here? Okay. Now he will move the tube up and down until he get a louder sound. Until he will get a louder sound. Okay, guys, pay attention to this. Do you hear this, guys? You know, at this length of the tube, I will hear a louder sound or amplified sound. Pay attention.
What is happening when we hear the increase in volume? It happens.
Guys, at this length of the tube, what does this mean? Listen. When I hear a louder sound, this means that a standing wave or standing waves are formed where in this length of air inside the tube. Standing waves are formed in this length of air in this tube. Okay?
And F equals 512 and F equals 256. Listen for the increases in volume. Watch where the tube is. The numbers are marked on the tube starting at 0 and in increments of 5 centimeters with markings every centimeter. Watch where the increase in volume occurs and measure, and record the length of the tube in your data table. Then use the equation that we went over to calculate the velocity of the speed of sound. This is the way we draw the node, antinode, node, antinode. Here's the closed end of the pipe. Here's the open end of the pipe. So this is really what's happening. Nodes are where there is minimum movement of air.
Okay. Now, after watching this demonstration about the standing wave like this, now look at this. Look how we will find the speed of sound using the concept of the standing wave, right? Speed of sound using this concept of standing wave. Look. Look here, guys. At specific length, the sound becomes louder, right? At specific lengths, the sound becomes louder. And here, the length is 25, right? Or the length of the tube is 25. If I repeat this again, I would show you, we have first harmonic and third harmonic. Look. This is the first harmonic. Do you hear? Which is around 7.5, something like this. Now, this is the first harmonic. Listen, listen. Now we will hear a louder sound. Did you hear? This is the next harmonic, right? This is what? The next harmonic. Here another ish source of sound. Another source of sound. هلا نيجي للستاندينج ويفز. اذا شفنا الستاندينج ويفز، شفنا الريزونانس كيف بصير. فعليا هذا هو الشكل الستاندينج ويفز، حتى هو بالفيديو شرح لكم اياه. اوكي، هلا هون في عندنا نود again، وهون عندنا ايش؟ نود. here we have anti node و here we have anti node. guys الكلوزد اند دائما عنده ايش؟ دائما الكلوزد اند نود والاوبن اند انتي نود always. if I want to describe الاوسيليشن تاعت البارتيكلز، طلع معي هون. guys here at nodes no oscillation for the particle and the particle will not oscillate. guys look to the antinode here, this position. it's the maximum possible displacement. هاي شايفينها هون اقل، طبعا هذا sound لانه clear. وهير same thing, maximum possible oscillation. هلا if I look here, we can also or we can represent this using the following thing. Here, explain how the resonance in the column of air is formed. We talked about this. We watched video about this, guys. We placed here a tuning fork, right? As a result of that, we will rise the tube up and down until we have the amplified sound. So at this moment, we know that resonance is taking place. Okay, resonance is taking place. Explain how the resonance in the column of air is formed. In the experiment, we had a tube. This tube is closed from one end by the water, and it can be moved up and down. Also, we used something called tuning fork. Tuning fork produces sound at certain frequency. Sound at certain what frequency? This is the tuning fork. Here, this was the tube that is movable. Then along the tube there is a scale. Here there is a water, as what we seen yesterday. We have to move this up and down until we have amplified sound or louder sound. At this, guys, at this length, a standing wave is formed where in the air inside here. In this air inside, there is a standing waves, because guys, at the standing waves, or when the standing waves are formed, the air particles will oscillate at their maximum displacement. As a result of that, we will have higher amplitude, right? We will have higher amplitude. So resonance increases the amplitude of the vibration, which can form standing waves in the tube. The length of the air column determines the resonant frequency. Okay, but amplify only what? The natural frequency. Air molecules will not oscillate. هلا, the second thing, which is at open ends, يعني we may have a tube like this, opened at both ends. Let's say here there's a sound generator. Here there's a loudspeaker, produces sound. Now we have outgoing waves, guys, here. When these outgoing waves, guys, reaches the second end, this end, what will happen here, guys? Here, partially transmitted or partially reflected. Because, guys, the air inside has different density than air outside. Because the air is inside more dense than the air outside, because it's trapped in a small size. If the volume decreases, the density will increase. So here, guys, this is a boundary. As a result of this different in density, this would become a boundary between two different media, right? Between two different media. So as a result of that, there are waves transmitted and waves are reflected. Consequently, guys, these waves, the reflected waves, right? The reflected waves and outgoing waves, again, guys, they will interfere constructively and destructively at certain positions, forming nodes and antinodes, as what we mentioned before. So here a standing wave is produced. Again, guys, all the standing waves, guys, are taking place at specific frequencies. At specific what? Frequencies. These frequencies are called harmonic frequencies. Okay. The end of the tube represents a boundary between the closed air in the tube and the expanse of air outside the tube. The sound will undergo partial reflection or partial what? Transmission when they reach the end, as what we mentioned before. Again, guys, when they reach the closed end, they reflected back with the same frequency amplitude, interfere constructively, destructively, and so on. Here, guys, we have to draw the wave pattern for standing wave in air column at both ends. Standing waves in air column open at one end, one at both ends. Guys, طلعوا معي هون. If it open or if the air column open at one end, here we have one node, because here I have antinode. طلعوا معي, please. How will I draw this? This is the first harmonic. You will be asked to draw this. Right? This is the first one. This is the second one. Here we have only one node. Here, always, guys, at the open ends, right? At the open ends, we will have what? Antinode. Here, node. This is the second harmonic. This is first harmonic. This is second harmonic. In the second harmonic, we will have two nodes like this. So I have to draw wave like this. Then another one. Should be a dashed line. حتى even here. Third, guys, I have to draw what? 3 nodes. I have to draw the waves like this. And they must be evenly spaced. Guys, pay attention to this, because you will be asked to draw it. I tried as much as I can.
أستاذ إذا كان open at one end only من عند المحل اللي هو closed فيه بيكون عندنا node.
Yes, I will show you that. هذا كان I'm drawing what wave and so on. هلا here guys the wavelength look here guys. According to the wave, what is this part? What is the fraction of this part from the wave? This one. Between the green lines. And if I consider a wave, this is a wave. Right? This part represents this. Right? What is the fraction of this? Quarter lambda. Guys, if I consider this part, this is a quarter lambda. So if I consider another one here, this part here, similar, between these lines, similar to this, صح? But basically here, this is quarter lambda, this is quarter lambda. So here the length equals what? Half lambda. So lambda equals ايش? 2L. Pay attention guys, because this is the way that you will find wavelength. طيب هلا let's go back again guys. Let me remind you by this. هلا basically guys, the best way, or since the wave has a pattern, I can divide the wave to main 4 quarters. صح? Like this. تمام؟ هلا هذا البارت quarter period. صح؟ which is similar to this part. هاي طلع معي. which is similar to this. وthis part another quarter period. فoverall قديش عندي أنا؟ عندي quarter wavelength وquarter wavelength. Sorry, and I meant quarter wavelength. Quarter wavelength to quarter wavelength, I got what? Half wavelength. So length of the tube here will show me what? Half of the wavelength. Is that clear? طيب, let me show you the second one. طلع معي كيف. I will divide this. هاي quarter. صح؟ وهون quarter. وهون quarter. Right? طيب guys, let's talk it in let's take it in another way, or from another point of view. I wrote a note before guys, in the distance between, remember please guys, between antinode and node, quarter wavelength. Do you remember this guys? It's easier. If we consider it like this, it might be easier. This is antinode, right? This is what? Antinode. Node, this is quarter wavelength. This is node, antinode, quarter wavelength. This is quarter wavelength. This is quarter wavelength. How many wavelengths here guys? Quarter, صح؟ وهذا quarter وهذا quarter وهذا quarter. كم wavelength راح يكون؟ 1. Between node, this is antinode. هاي quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters. Sorry, لا مش هيك طبعا. هذا آخر كوارتر طبعا من هون هاي كوارتر، صح؟ 2 quarters, 3 quarters, 4 quarters, 5 quarters, 6 quarters. يعني basically here L equals ايش 6 over 4 lambda اللي هي الانتينود. It might be similar to the crest يعني انه we may or it may be looked similar بس هي it's not a crest, it's an antinode. طيب basically here guys I can طبعا frequency this is fundamental if note. الحمد لله. This is second harmonic, this is third harmonic, and so on. Here guys if I want to write the conclusion, lambda here is 2L over N, و F here equals ايش N F note. هاي الكونكلوجن او الباترن اللي احنا شفناه. والN بتعرفوا الN هي الاوردر اوف ايش اوف هارمونيك، الاوردر اوف هارمونيك. و number of nodes here equals N. يعني إذا أنا عندي هون 1 harmonic عندي 1 node، 2 harmonics 2 nodes، 3 harmonics 3 nodes, and so on. Guys, these are important if you are asked to draw this. Okay. Pay attention, guys. This is first harmonic, right? This is first harmonic. How many nodes must be here? 1 node, right? As what we mentioned before, guys, at closed end we have node. At open end we have antinode. So we have only 1 node here. So I may draw the wave in this way. This is the pattern of the wave, right? This is the pattern of the wave that will be observed. How do I know this, guys? Because we have only one node here, one node here at the closed end, and one antinode where at open end. Okay, at open end. Right. Here, length has how many wavelengths in this length? Then if I consider the length of this, how many wavelengths in this length?
half lambda.
Half ولا quarter؟ بين antinode ونود دائما عندنا كوارتر لامدا. تمام؟ فهذا شو بده يكون؟ كوارتر لامدا. طيب نروح next harmonic. Listen, طلع يا what will I say now? The next harmonic, not the second, the next harmonic. I will show you why. هلا next harmonic, how many nodes must be there? ايضا كم نود عندنا؟ شوف بالضبط. هاي 2 هاي 1 هاي 2. خلينا نرسم الويف يكون هيك. صح؟ والثانية كلير؟ طيب هون عندنا انتي نود نود نود. تمام؟ هلا من انتي نود لنود عندنا كوارتر لامدا، صح؟ ومن نود لنود عندنا هاف لامدا. طلع كيف احنا عرفنا؟ احنا عندنا السكند او نكست هارمونيك كم نود فيها؟ 2. هي حطيت واحد because end لازم واحد يكون بالنص. اوكي كلير يا زلمه؟
اه
If there's any problem, but ask me please. I may read the answer.
اوكي
Quarter period. طيب هون قد ايه راح يصير اللينث هون؟ 3 over lambda صح؟ 3 quarters يعني معناته اللينث قد ايه بيساوي؟ 4 lambda over 3 سوري lambda
فور ال لا
ايوه lambda 4 L over 3 تمام؟ طيب ناخذ النكست harmonic. How many nodes must be?
3
This is ايش صح the wave that we have to draw. طبعا they must be evenly spaced by the way. When you draw them تنتبهوا انه they must be evenly spaced nodes يعني as much as we can. يعني this way somehow this will be this one. طبعا here this is anti-node, node, anti-node, node, and node, right? إذا how many quarters here? So length here is 5 over 4 lambda. So lambda equals 4L over 5. Can you find the pattern? تقدر تطلع لنا الباترن؟ لنا الباترن لللامدا on 4L on 4L over 3 on 4L over 5 صح؟ يعني بمعنى words guys انه الدينومينيتور هو odd integer صح؟ عم بيطلع معي مين؟ odd يعني الباترن here odd صح؟
اه
This means انه انا ما عندي even harmonics، انا عندي odd harmonics. يعني هذا third harmonic، هذا fifth harmonic. فهمت الفكرة كيف؟ انه بالclose there are no even harmonics. There are no even harmonics. كلهم شو بيكونوا؟ odd harmonics. يعني هون lambda equals 4L over n و n must be odd. والفريكونسي راح يكون برضه ايش؟ n في f note و n odd. يعني هون هاي f note صح؟ This is 3 f note. This is 5 f note and so on. يعني here guys we will not have any even harmonics. كلاتهم راح يكونوا عبارة عن odd. Clear? Look to the standing wave in air, but open at one end. Open at one end. Okay guys, طلع معي هون. هلا as what we mentioned before here antinode. Here what? Antinode. Here sorry here node sorry I meant sorry here node وhere antinode. تكون هيك شكل الويف. لانه دائما الفيرست هارمونيك لازم يكون في one node. The second harmonic does not exist. The second harmonic does not exist. The third harmonic هيك بيكون. Okay. The fourth harmonic does not exist, and so on, guys. بالاوpen او air column open at one end, even harmonics ايش are not exist. طيب هون مين يعطيني هاي distance قد ايه؟ Rand. What is the distance between antinode and node?
هلا هاي
Yeah. لا first one في الفيرست harmonic. كم؟ كوارتر لامدا بالضبط. يعني هذا اللينث جايز، هذا اللينث اللي هون هو كوارتر لامدا. يعني لامدا ايش بتساوي؟ 4L. قلنا second harmonic does not exist. نيجي هون على الثيرد harmonic. طلعوا معي هون. هاي كوارتر لامدا، هاي 2 quarters، هاي 3 quarters. هاي كوارتر، هاي كوارتر، هاي كوارتر. Guys, it's easy. يعني you have to follow this pattern. From antinode to node, quarter. From antinode to node, quarter. From antinode to node, quarter. So here the length هو 3 quarter of lambda, which means إنه lambda بتساوي 4L over 3. طبعا اتفقنا إنه الفورث harmonic is not exist. طبعا هون fundamental frequency F note, here 3 F note, and so on. So the pattern here, if I want to find the pattern, lambda equals 4L over N, و F equals ايش؟ N F note.
بس انا مش فاهم اخر اشي هاد، بس انا بس حكيت ايش لامدا ايكوالز وايش
هلا
اف ايكوالز.
متفقين على طارق انه من النود تو انتي نود عندنا كوارتر لامدا. طيب معناته اللامدا شو بتساوي؟ 4L، صح؟ وهي
اوكي
زي ما حكينا اتس نوت اكزيست، يعني ما راح يطلع معي سكند هارمونيك، راح يطلع معي ثيرد هارمونيك. يعني النكست هارمونيك مش سكند، ثيرد. هلا قسم هاي. طبعا احنا هون عندنا اتفقنا كم نود؟ 2 نودز. هاي 1، هاي 2. I draw this wave in this way. طبعا هذا السكند هارمونيك like this. هلا عد كوارترز، هي بين انتي نود ونود كوارتر، بين انتي نود ونود كوارتر، وبين انتي نود ونود كوارتر. فانا عندي 3 كوارترز. اذا بدي اطلع لامدا بتصير 4L over 3. ففعليا ال standing wave in that is formed او standing waves that are formed in air column open at one end هي الباترن تاع الويف لينث فيها 4L over N. طبعا الفريكونسي احنا دائما ان اف نوت. اتفرجوا معي. هلا انا عندي 3 main things. تمام. first one السترينج، closed end و open end. السترينج الويف لينث 3 standing waves. One standing wave in string, the other in closed pipe, the other were in open pipe. You can find هذا السمري كامل. هلا بالclosed pipe اللامدا بتساوي 2L على N، وبالاوبن اند اللامدا بتساوي 2L على N. ما عندنا مشكلة. بس بالclosed end لامدا بتساوي 4L على N. هون no odd no even harmonics. هلا بقولكم ليه. هون طبعا كل إشي، بس هون عندنا ما في عندنا even harmonics. والفريكونسي as well هي F equals N في F note. طبعا you have to know how to draw everyone. هلا ليس المين point guys here إنه standing waves does not occur at all frequencies. Standing waves guys are occurred at specific frequencies where outgoing waves والreflected waves interfere constructively at specific positions وdestructively at specific positions. هلا if I consider a second harmonic I will not observe any standing wave. يعني ما راح يطلع لنا standing wave، ما راح نشوف amplified sound like the video that we watched in the previous time. هلا بالفيديو in the previous time this is what he did. Pay attention guys. هلا let me explain this also in another way. In why we will not get a second harmonic or second harmonic guys. Okay. هلا قلنا this is a closed end pipe. Closed end pipe. So here there is an antinode. Here there is what? Node. If I took the next harmonic, I will have two nodes. هذا الطبيعي. Right? In the next harmonic يطلع عندي how many nodes? Two nodes. طب if I consider these two nodes like what I did here. هاي. These nodes. Right? If I consider now this أنا أخذنا إنه بالsecond harmonic ركزوا معي عشان to understand the answer. هلا in the next harmonic after the first harmonic we should have two nodes. We should have how many nodes? Two nodes. This is the two nodes that are formed. So according to the analogy that we took here, L equals 3 over 4 lambda. So lambda equals 4L over 3. If I continue in this way, guys, if I continue in this way, I will observe that N must be odd. And I follow the order. I will follow what? The order. Okay? If I continue in this way, and if I took مثلا next harmonic, guys, ركزوا معي. مش راح أحكي fifth هلا. راح أورجيكم كيف راح how will I deduce إنها it's a fifth harmonic. هلا after this one, in next harmonic, how many nodes must be order away from the اللي هو ordering إنه first to third و fifth and so on. طلعوا معي. هون عندنا one node. In next harmonic لازم يكون عندنا how many nodes? Two nodes. In next harmonic لازم يكون عندنا 3 nodes and so on. صح ولا لا؟ هذا الباترن تاعنا اللي احنا we are following. طيب if I draw a wave هلا طلع معي هيك هاي standing wave like this عند ال open end anti node now we have to
يعني الفيفث ريزونانت
يكون
لينث
عنده 3
عنده
nodes
3
عشان
نوتس.
هيك هلا بنعرف ليش طلع ليش سميناه fifth. هلا بنعرف ليش لانه احنا we are following ال pattern. هلا if I again consider the same analogy here هاي node anti node anti node 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 anti node node node. How many quarters here? 1 2 3 4 5. يعني basically guys here L equals 5 over 4 lambda. So lambda equals what? 4L over 5. Guys, if I follow the pattern, I will observe إنه أنا عم بيطلع معي مين؟ بيطلع معي بس الأود. إيش؟ بس الأود harmonics مش الإيفن harmonics. فهمتوا ليش إحنا سميناهم first و third و fifth and so on. أنا مشيت على الباترن. طبعا دائما هيك جماعة الباترن. الباترن بالستاندينج ويفز أول standing waves has one node, the second one 2 nodes, third one 4th nodes and so on. This is if I consider them next harmonic as a next harmonic, not as an order. If I follow the pattern, I will find that it will be 4L over N, or N it will be an odd value. So this is why we exclude here even harmonics. Okay guys, هلا بالexperiment that we watched in the previous time إنه he will move this column of air up and down until he gets a louder sound. صح؟ لما بسمع louder sound معناته what does this mean؟ إنه الفريكونسي تاعت التيونينج فورك equals to the frequency or harmonic frequency or one of the harmonic frequencies تاع مين تاع الاير. هذا اسمه resonance. At this frequency guys ايش بصير بالsound؟ ايش بصير بالsound؟ amplified. Is that clear? If I move the distance or if I move the tube up, I'll have more air inside the tube. So at specific length, I will have the second resonance or the second or the next harmonic, which is the third harmonic, and so on. Clear, guys? Any question about that? Guys, construct an experiment to demonstrate standing waves in sound. Guys, pay attention. You will be asked about these things. In experiments to form standing waves in sound. Here we have two ways. First way, look here please. I will bring a sound generator, speaker connected to a sound generator, microphone here, reflector. Guys, طبعا accordingly here فين outgoing waves وhere reflected waves. These waves will interfere constructively and destructively, forming a standing wave. طبعا this standing wave will be at specific frequencies. In order to check this, I have a microphone. This microphone will be moved horizontally this way. At certain position, the microphone here shows a lower amplitude, which is node. At certain position, will detect higher amplitude, which is anti-node. Again, node, and so on, guys. And what? So on. By using this, by using the measurement between node and antinode, I can find the wavelength, right? This is half wavelength. Between two successive nodes, this is what? A half wavelength. طبعا I can measure this distance using what? Using a ruler. So if I measure the distance between two successive nodes, I can measure the wavelength. Well, I have the frequency here. I can measure the speed of sound. And this is another way, guys, of measuring speed of sound. And I may measure the speed of sound using the standing waves that is formed between loudspeaker and reflector. By measuring the distance, and you will be asked about these things, pay attention. By measuring the distance between two successive nodes, let's say this distance will be half lambda. So you can find lambda. Well, after that, the frequency found or from frequency generator or loudspeaker. Accordingly, guys, the speed equals what? Frequency times lambda. I can find the speed of, or I can measure the speed of sound in air. All the details, guys, is mentioned here. Also, I can form a standing waves in or using a microwave source. Same thing, guys, but instead of the microphone here, I have to use something called diode receiver. هذا الدايود receiver connected لمثلا ammeter or voltmeter. Same thing, guys, I have to move this diode receiver هذا بيكون connected لاميتر او sensitive ammeter or sensitive voltmeter بصير يعطيني reading لcurrent or potential difference. Okay, at certain position بيكون low potential difference or low current. At certain position بيكون عندنا higher, lower, and so on. So here node, anti-node, node, and so on. By measuring the length between two nodes, we can find the wavelength, and the frequency of the microwave is given, so we can find the speed of microwave. This is the experiment that we watched in the previous time. It's called resonance tube. It will be used to measure the velocity of sound. What he did, guys, you will be asked about these things as what he mentioned before. We used tuning fork, guys. Tuning fork, when it's hit by anything, it will give specific sound at certain frequency. تمام? At certain what? Frequency only. It's given to this. What I have to do, guys, as what you see before, I have to move the tube up and down until I get the amplified sound. The first amplified sound. The first amplified sound. The first amplifying sound, this means that this is the first harmonic. I will measure this length. Okay, I will measure what? This length. Guys, since this is a closed tube, lambda is equal for L over N. The first sound, the first loud sound heard, هذا راح يكون الفيرست harmonic. طيب السكند loud sound شو راح يكون؟ كان عندنا هذا التيوب was moved up and down until we heard louder sound, right? Until we heard what? A louder sound. هلا at specific length we will hear أو the first louder sound راح يكون عند الفيرست harmonic. طيب السكند louder sound وين راح يكون؟ الاوبن اند guys, الاوبن اند tube, sorry, the closed one end tube does not show any even harmonics, فهذا راح يكون الثird harmonic and so on. So I have to change this until I have to repeat this procedure, right? First of all, set the apparatus as shown. Strike tuning fork on a rubber bunch, not pinch it or hold it over at any end of the tube T. Move the tube up and down until resonance position is obtained and measure the length. Repeat the procedure with other tuning fork. For each resonance, measure what? The length. For each length, find the wavelength, which is 4L, because the wavelength 4L over N. We will select the first order, guys, or first harmonic. يعني when I change when I use another tuning fork, I will record the length for the first harmonic or for the first loud sound be heard. Okay, الاناليسز هلا بنعمل we have to draw a graph. طبعا احنا we are changing frequency. Here we will consider 1 over L. As a result of that, I will have this graph. The gradient of this graph is V over 4. So by measuring the gradient, I can find the velocity of the sound in air, right? I can find the velocity of the sound where? In air. Okay. Before starting with the questions, let me show you how we do this. You know this, guys. Let me start from this. Frequency equals what? Velocity over lambda. Clear? Lambda equals what? 4L over N. Since we will consider the first order, so lambda will be always 4L. Substitute here. Oh, العكس, sorry. Frequency versus 1 over L. Frequency, right? Frequency versus 1 over L. طيب, طلع معي كيف هلا رح أعملها. Please pay attention, guys. I will rewrite this equation as F equals V over 4, 1 over L. Just rearrange the equation. This one along the y-axis. This is why I draw here not L, 1 over L. So the relation will be linear. So the relation will be linear. Equals mx. So the gradient here is V over 4. So if I want V, V equals 4 times the measured gradient. Any question about that, guys? Next time we will start doing the questions and the past paper questions as well.